Question number 2. You're designing a glass vase. It will be a rectangular prism with an outer surface area of 225 centimeters squared, a square base, and no top. So I've got a vase here. The vase is square at the bottom, but the height is somewhat different than the base. So we know that it's not a cube. Now, just to recall, the way we solve these types of questions, first of all, we're going to determine our equations. Determine equations of the fixed and optimized variable. Okay, the second thing, we're going to rearrange the fixed variable then we're going to substitute it into the optimized. And you're going to solve with technology, if necessary, or algebra. Now this question, since it is a little more complicated, we are going to need technology to do this. So first of all, we know that our two values that we are talking about right now is volume and surface area. So step 1, let's write the equation of this. Volume, I'm going to draw my diagram again. So here's my vase. I know that the length and the width are the same, so I'm just going to call it width times width. And I have my height. Those are the 3 dimensions that we're talking about. So volume in this case is length times width, which is W times H. I'm going to rewrite that as W squared times H. This is our optimized value. The second one that we have is surface area. Surface area is fixed. They've told us that surface area is equal to 225 centimeters squared. Now, to get my surface area equation, I'm going to have to think of the net of this shape. So if I were to open it up, I would have my 4 sides and 1 bottom because the top is an open value. So I have here 1 square, that's W squared, and I have 1, 2, 3, 4 rectangles that are H times W. This value is our fixed one. So let's take our second step, rearrange the fixed variable so that I can substitute it into my optimized. So surface area, 225, is equal to W squared plus 4HW. Now I've got a W and W squared here. That is going to be a little bit tricky to work with, so I am going to solve for H so that I could substitute H into volume. Let's isolate for H. So I have 225 minus W squared is equal to 4HW. Let's divide both sides now by 4W because this way I have H on its own. These divide out, that divides out as well. So H is equal to 225 minus W squared over 4W. Now this looks messy, but we're going to substitute it into this equation and let the graphing calculator do the rest. Okay, so our next step, sub into volume. Volume, we know, is W squared plus H, as we've established there. So when I rewrite this, I have W squared times 225 minus W squared, all divided by 4W. Now, we're going to take Desmos and substitute it into, or just punch it in. So let's use x squared, big bracket, I'm going to do two brackets, 225 minus x squared, close my first bracket, then we're going to divide it by 4x. Okay, so we have this graph here. Let me try to fit it better for my purposes. Okay, and I have a maximal value of 8.66 and 324.76. Let me resketch that here. You know that here, my maximum 8.66 and 324.76. My y value, this is my volume, and my x value is representing the width. So we know that the maximum volume that we could have is 324.8 centimeters cubed. And when the width is 8.6, we would have the maximal volume. Now we need to substitute it back in to get my H. So sub W is equal to 8.66 into H is equal to 225 minus W squared over 4W. So we have 225 minus 8.66 divided by 4 times 8.66. Okay, let's use our calculator for this. We can just go back to this. Now I'm going to have 8.66 and then 4 times 8.66. The height that we get is 4.33. So, with the conclusion, the dimensions will be 8.66 times 8.66 times 4.33 centimeters. And the maximum volume is going to be 324.8 centimeters cubed.